All right, we're going to continue our discussion on two-column proofs. Today's primary focus is segment addition and angle addition. It's going to be a banger. We're going to do two of them. So let's start out with this segment-looking guy. We have ourselves, we're given this picture, and we're also given that AB is congruent to CD. So I'm going to get myself a nice little Post-it, patent pending, and I'm going to make myself my rough draft. Okay? So this is what you're looking for. Let's state what you already know, that AB equals CD. Cool. With a lot of these proofs, what you're hoping to do is find out when things are equal to each other, if there's a way that you can get rid of it. And a lot of times with the angle and segment addition postulates, you just end up saying stuff like this guy plus that guy equals that guy. And this guy plus that guy also equals that guy. And then you can set things equal to each other and cancel things out. We're focusing on getting AC and BD equal to each other. So the way I'm going to try to set this up is do some type of segment addition that involves AB, CD, AC, and BD. All right, I want to try to involve all of them. So I know that if I have AB, I can add BC and CD to get the whole thing. But better yet, if I have AB and I add BD, I have BD down there, and that might become super convenient. So I already used AB check and BD check. Could I use CD and AC in the same way? Sure. AC plus CD also equals AD. So now that I know that they both equal AD, I can say that AB plus BD equals AC plus CD. Right? Why is that helpful? Because AB and CD are the same thing, which means these two guys will disappear. How am I going to show that? I'm going to keep AB there. I'm going to turn CD into AB. So that when I subtract AB from both sides, I end up with BD equals AC. Okay, so what did I do up here? When I take two segments and I add them to get the anything else, I use the segment addition postulate, SAP. I did it again. Oops. I then said, since this guy is AD and that guy is AD, then this guy equals that guy, and that is the transitive property. You could also use substitution. But what I did here is I did substitution by turning CD into AB. Oh, then I did and that's how I got that guy. So let's all put it together. Let's see. Let me see if I can make it all fit. Statement. Reasons. All right, so statement number one is my given. Always my given. AB equals CD. I'm sorry, AB is congruent to CD, and that's my given. I guess what I really ought to say next is, since I'm given AB is congruent to CD, I need to say that AB equals CD, and that's the definition of congruence. Don't want to forget that. I mean, I know, but I don't want to forget it. I don't want to forget writing it down. You never know how picky your math teacher is. And I'm very picky. 3. I'm going to write all that out. AB plus BD equals AD, and also AC plus CD equals AD, and that was the segment addition postulate. Also, what's next? Since AD equals this and AD equals that, I can use the transitive property by saying AB plus BD equals AC plus CD, and that's the transitive property of equality. I'm going to run out of room. Time to write smaller. 5. I'm going to turn CD into AB. So, and I did that from my given. Technically, I did that from step 2. But AB plus BD equals AC plus AB. And that is the substitution property of equality. I can now subtract AB from both sides, which gives me, if AB goes away, BD equals AC. And that's the substitution, subtraction property of equality. And last but not least, I have to change it back. Actually, I have to do 2 steps. Darn it. Darn it. AC equals BD, and that's not the reflexive, symmetric property of equality. So what I'll do here is I'll put symmetric PO and then 8 is AC is congruent to BD, and that's the definition of congruence. Okay, sorry that I got sloppy down there. I thought I said, I thought I gave myself enough space, and I was 1000% wrong. But there it is. Take it in, kids. Breathe it in. Breathe it in. Goes down smooth. That is a quote from the Anchorman. Let's get another Post-it note. All right, similar problem. Again, you'll notice that this problem has the same, I want to say, behaviors as the previous problem. I have lots of givens. So I have given blah, 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 blah. From what I'm given, I can say that 1 and 2, the measure of angle 1 and the measure of angle 2, add up to 90 degrees. And that's the definition of complementary. Okay, def of comp. Same thing with 3 and 4. And just like the last problem, oh look, they both add up to 90. So I should be able to say M angle 1 plus M angle 2 equals M angle 3 plus M angle 4. What did I do there? Transitive property of equality. Ran out of room. Transit sounds good though. And just like the last one, I know that angle 1 and angle 4 are congruent to each other. So I probably need to say that the measure of angle 1 equals the measure of angle 4, and that's the definition of congruence. And once I say that, I could say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle, oh, well, 4 is 1, so that measure of angle 4 again. 1, 1, 1, 1, 1. And I did substitution, property of equality. These two cancel. By subtraction. And then I can say this. Oh my gosh. Ugh. I can say that. Very eerily similar to the last one. So eerily similar to the last one. I'm probably going to need a whole lot more space than I gave myself. So let's put it all over here and write small. Statements. Reasons. All right, let's get my givens out of the way. Let's get all my givens out of the way. Angle 1 and angle 2 are complementary, so I'll put comp. I'll also say angle 3 and angle 4 are also comp. And I'll say that angle 1 is congruent to angle 4, and all of those are my givens. The measure of angle 1 plus the measure of angle 2 is 90 degrees. Also, the measure of angle 3 plus the measure of angle 4 are also 90 degrees. And the reason for that is the definition of complementary. Complementary means there are two angles that add up to 90 degrees. If they both equal 90, then they equal each other. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. That's the transitive property of equality. And what I should have done is I should have just printed these out on two separate pieces of paper. Look at me trying to save a nickel. All right. I also know that if 1 is congruent to 4, then the measure of angle 1 is equal to the measure of angle 4, and that's the definition of congruence. Which means that I can just turn 1 into 4. Is that how I did it? No, I turned 4 into 1. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 1. And that was the substitution property of equality. So 1 and 1 cancel each other out. So the measure of angle 2 equals the measure of angle 3, and that was the subtraction property of equality. And last, but certainly not least, I can now say that angle 2 is congruent to angle 3, and that is the definition of congruence. Very, 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 very similar behaving proofs. And in each of them, I used oh, actually, no, I didn't. I was going to say I did some kind of angle addition postulate, but I didn't do an angle addition postulate. I just did the definition of complementary. But in either case, it seems like what I had to do is I had to say this plus this equals that. And two other things also equal that. So set them equal to each other, substitute something in, cancel it out, then you're done. And then we have these other properties like congruence to remember. Okay? And up here, symmetric. All right. That'll do it. Bye.